Hey, this is Brent Ritchie. I am going to work a couple problems, discrete probability distribution problems. The random variable X represents the numbers of cars per household in a town of 1,000 households. Find the probability that a randomly selected household has less than 2 cars. And then find the probability that a randomly selecting a household that has at least 1 car. So we have some data to share here. So give me a second to do that. Okay, we have a little table of data here with the number of cars and the number of households who own that many cars. And I'm going to add a probability for each one of these. Probability. So some families have 0 cars, some have 1, 2, 3, and 4. And of the 1,000 households, 125 had 0 cars, 428 had 1, 256 had 2, 108 had 3, and 83 had 4. Yeah, at this point, this is really a frequency distribution, but we can turn it into a probability distribution by calculating the probability for each one of these events. Now we know that this column totals up to 1,000, which makes the math easy to find all these probabilities. We just divide the frequency by 1,000, and we get all these probabilities here. Then we're asked the question, what's the probability of randomly selecting a household and seeing that they have less than 2 cars, less than 2? Well, that is going to be, when we say less than 2, we mean 0 and 1. So that is those 2 rows. So we have a probability of 0.125 plus 0.428, and that gives us 0.553. So the probability of selecting someone at random and that person living in a household with either 0 or 1 car, which is less than 2, is 0.553. Second part of this problem, probability of random selecting a car that has at least 1 car. There's actually 3 parts of this problem, at least 1. So that's greater than at least 1 car. That's greater than or equal to 1. Because when we're talking about at least 1, we are talking about these groups down here. So let me get rid of this box and highlight the at least 1 right there. Now, if we add up all these numbers, we see that there's only one number that's not included in this. So since they all add up to 1, it's a little quicker to subtract the 0.15 from 1 and get 0.875. So the probability of having less than, or at least 1 car is 0.875. The third part is between 1 and 3 cars inclusive. We want this random variable number of cars to be between 1 and 3 inclusive. Now, when we word it that way in math, we mean between 1 and 3 would just be, if we said just between 1 and 3, that would be 2. But we're saying between 1 and 3 inclusive, so we're including the 1 we're including the 3. So between 1 and 3 inclusive are those right there. Add those up, 0.428 plus 0.256 plus 0.108. Is that 0.792? So the probability of them having between 1 and 3 cars inclusive is 0.7912. That is a discrete, using a discrete probability distribution with empirical data.